Hi. Okay, next lesson, the last lesson in this chemistry topic, which is metallic bonding. And by the end of the lesson, we're going to be able to describe the structure of metals and their properties due to their bonding. Why are metals the way they are? And it's because of their bonding, and you'll be able to explain that. But to start with, there are 4 questions, and you need to answer these 4 questions. The first one, name, give, state. 5 examples of a molecule, that isn't bad grammar, sorry. 5 examples of molecules that are covalently bonded. 4 examples of a molecule that is ionically bonded. 3 allotropes of carbon. And what properties of graphene makes it so special? Okay, pause and write the answers down. Have you done it? Did you really? Are you just waiting for the answers? Suspicious. Show me the evidence. Okay, let's go to the answers. Right, here we have covalently bonded molecules. So we have a molecule of hydrogen, H2, a molecule of nitrogen, N2, a molecule of water, H2O, CH4, that's methane, and CO2, carbon dioxide, all nonmetals, all covalently bonded to one another. The next one, Wake said ionically bonded, and so with ionic you need a metal and a non-metal, and we have NaCl, sodium chloride, KBr, potassium bromide, MgO, magnesium oxide, and Al2O3, which is aluminium oxide, all ionically bonded. Number 3 was an allotrope of carbon. Different allotropes of carbon. We have diamond, graphite, and we also have fullerenes. What is a property that makes these so special? They are excellent conductors, and they are incredibly strong, just like me. Okay, what are the general properties of most metals? My head's in the way for the S. Maybe you should do that. Pause. Write down the properties of most metals. I've already done it. I'll show you in a second. Have you done that? Excellent. Did you get these ones? Did you put them in an orange box? They're solid at room temperature. They have a high melting point. They are good conductors of electricity and heat. They are malleable, as in you can shape them, normally with a hammer. They are ductile, can be drawn into wires. My drawing into wires, mine. They are strong. And they are dense, which means they're a lot of mass in a small amount of space. Why do metals have these properties? That is the aim of today's lesson. Okay, so metals are arranged like this. Here's a nice little diagram. Maybe you draw that. They are arranged in a lattice structure. So that kind of makes them a bit crystalline, which means they're arranged normally in rows, neat rows. You can see here they're kind of rows, but they're slightly offset. So there's row, and then the row below is just kind of slightly to the side, and the row below that to the side. So they are arranged in a nice, regular lattice structure. And they have these electrons, and these electrons kind of are around the outside. We know that. Normally, they have about one, in a good metal, kind of like copper, they have like 1 free electron per atom that they kind of give to this sea of electrons. So they're all surrounded by a sea of electrons. So there are loads of electrons that just kind of fill in between the gaps of these metal ions. These electrons are called delocalized, as in they are not fixed to one atom. They can move around from atom to atom. So delocalized means the electrons can move throughout the whole structure from one to the other. So this electron here can travel all the way down here and back again if it wanted to. Why not? Like, it is delocalized, it is free to travel. And so if the metal atoms are positively charged because they've given up one of their electrons, and then the electrons are negatively charged because they're electrons, the whole thing is attracted to itself. So it is, that is what metallic bonding is. The positive of those atoms and the negative of those electrons makes this metallic bonding. Okay, most metals, apart from one, have a very, very high melting point. For example, gold has a melting point of 1,000 degrees, 1064, boiling point of nearly 2,807. The reason they have these incredibly strong melting and boiling points, so to melt an element or an atom or something, a material, is when you have to kind of break the bonds. So, the atoms are kind of held together like this, and if they're solid, they're fixed in position, and if they're liquid, they can kind of move, and if they're a gas, they can separate. So to make them change state, you need to provide enough energy so initially these atoms can break apart, so they can start to move over each other, and then if you want to boil them, you have to give them so much energy they can jump away. But this metallic bonds, they're so strong, so the positive atoms and the electrons have such a strong bond, it requires loads and loads and loads of energy to break that apart. So, as it says here, this is because the really strong attraction between the positively charged metal ions in the middle and those sea of electrons. And so, a little bit of energy isn't going to be enough to break them apart. That's why you need thousands of degrees of temperature corresponding to a lot of energy to break those electrons and those positive ions apart so they can start to melt and even boil. So if you're doing any work with metal, you normally need incredibly high temperatures for this to occur. So why metals have high melting points? It's that strong attraction between those sea of positively charged ions and the electrons. Why do they conduct heat and electricity? That is because, if you remember, there's my little pen, these electrons, colour one in, is they can move, okay? So when you heat them, this electron starts vibrating and it gains energy. And if it gains energy, it can travel along and it can bounce into other ones. And when it bounces into other electrons, it gives them energy as well. So they kind of transfer their energy. So because those electrons are free to move, they can transfer their energy that they gain from heating or electricity throughout. So when they gain energy, they can move, they transfer it. And also, if they gain more energy, so they get hotter, they get even more energy, so they can move even faster, so they can transfer their energy better. So why are they good at conducting electricity? It's because they can move. I don't know why that. They can move, and when they move, they can transfer their energy, so they transfer their energy through the material. Delocalized electrons conduct electricity in a similar way. The movement of delocalized electrons allows them to be a great conductor. Two things, check that out. Metals are usually strong, not brittle. Oh, my head is in the way. They're strong because they've got these layers. So here we go. Here is a metal structure, so nicely, neatly arranged. If you hit it, all that happens is the metal ions just kind of shift. So here we go. You strike it, because that attraction is still there. The atoms, so the metal ions, these positively metal ions here, and these electrons, they're all still attracted. All that's happened is when you hit it, you've just kind of nudged them over a bit. So that's why they're incredibly strong, because the cause of hitting them, smashing them, doesn't cause them to break apart or snap like a brittle material like a biscuit or glass. Hitting the energy just kind of shifts some of the atoms along, so therefore they kind of lock into place into another position, still together, so they're strong. So you can't break them apart very easily. That's what makes them strong. Metallic bonds do not break because the delocalized electrons can move. There we go. So that's why you can shape them, because if you hit them, what happens is the atoms slide across, but they're still joined together. So if you hit something and it breaks off, you can't change its shape. Whereas if you hit it and the row of atoms jump across, and now it's just a new shape. And you keep doing that, and you keep doing that, shaping it, and that's why metals can be shaped into whatever you want them to be. An activity. My head is in the way. So what I need you to do is copy this down. What it says along the left-hand side, it says metal property: ductile, malleable, thermal conductor, electrical conductor. What does this mean, and why metal has this property? So why is a metal ductile? Why is a metal malleable? Why is a metal a good thermal conductor? Why is a metal a good electrical conductor? And then in this one, where my head is in the way, examples when this is useful. Can I move this? It won't. If I try and move this, it crashes the video, so I'm not going to do that. Examples of when it is useful. have that. Put this back on. So pause, fill that in. Okay, have you done that? I'll give you the answers to this next time round. So this one you'll have to do, you can't cheat. Haha. You can do this one yourself as well. There's a little quiz. So I'll upload this PowerPoint to the BLE so you can do this at home. What else are you going to do? Okay, so we're now onto the different types of metals. An alloy is a mixture of a metal with at least one other element. Most alloys are actually two different types of metal, two or more different types of metal, but there are some where you can have different things added in. For example, the most common one is steel. It's iron with a tiny bit of carbon mixed in. And if you add a tiny bit of carbon or another metal, you completely change the property by adding a new element. So often alloys are very different to the original material. Here we go. Here are some examples. Alloys. Brass is an alloy of copper and zinc. It doesn't tarnish. What does tarnish mean? It means when it gets to air, it can rust or change color. Copper often goes green. Zinc can go a bit dark. So if you mix the two together, it doesn't. And so you get things, well, brass used for musical instruments, so they don't rust with air and water. They keep their nice shininess. So that's brilliant. Solder is an alloy of zinc and lead. Makes it really easy to melt and incredibly flexible. Amalgam, an alloy of mercury and silver, is used in dental fillings because you can shape it, which is really handy, and it resists corrosion. Steel is an alloy of iron and sometimes other elements. Steel is much stronger than iron. As a consequence, it can be used for anything from saucepans to bridges. More importantly, though, not more importantly, I think the other thing for saucepan, iron rusts. Steel doesn't rust, which again, incredibly important if you're having a saucepan. You don't want a rusty saucepan, but you also don't want your bridge to rust, because if your bridge rusts, it will fall apart. It makes it stronger. The reason it makes it stronger, so in this diagram where my head is, that is a normal lattice arrangement of iron. And you can see the atoms of iron are nice and neatly arranged. 1, 2, 3, 4, and they're arranged, and they all kind of fit together in that lovely lattice. And we know they're malleable, so you can hit them, and what would happen is maybe those top row might shift along. So you're changing the shape, because they can do that because it just kind of slides across. It's the way they're fit together. If you throw in a new element, for example, you throw in some carbon, maybe some bigger elements, that's not nice and neat. That's not a neat lattice. So when you hit it, it's really hard or really difficult for it to change shape, because it's there's no simple method for those atoms to slide across. So here, the atoms can slide across really simply, across from the top, form a new bit. Whereas down here, if you hit this one, there's nowhere for it to go. And so steel is really strong, because by adding the extra elements into it, it stops that regular, nice, neat structure being neat, and so therefore the atoms can't move when you hit them. So that's why steel is much stronger than iron. There we go, I just said that. It's much more difficult for the layers to slide over each other. So this is why it's stronger than pure iron. Okay, so here are some... see if it crashes when I do this. So what is meant by an alloy? Why are alloys harder than most metals? Explain why metals generally have a very high melting point and boiling point. And for each of the following, suggest, do you think it would be better have a pure metal or an alloy? So I just want you to write down the answers to these. I don't care about writing the question. 1A, B, 2, 3, A, B, C, D, E. So you just need to answer the question, write them down in your book, and you take a photo and you send it to your teacher, proving that you've learned. I will give you the answers to these next lesson. So you actually have to do the work. You have to go back and look at the PowerPoint, listen to me again, my wonderful voice talking about all of these things. Okay, so answer those questions. I think that's it. Easy. Okay, all right, that's the end. Love you, bye.